Hello Legacy. So today we're going to look at graphing absolute value equations. We're going to expand beyond lines. Yay! What you're going to want to be able to have today, notes. You're going to definitely want that graphing notebook you bought, pen, pencil, and you may need a calculator to do some simple math today. Your learning objective, I can graph an absolute value function using a table. You're also going to want that foldable you got as well in class. So absolute value functions, what do they look like? Well, there's this knowledge known as a parent function. Absolute value, what that looks like, you're used to it as with the bars. Do you remember talking about the bars? They made every number inside of it positive. Well, that has a graph if we put an X in it. So the parent function of our absolute value is absolute value of X. Let's figure out what its graph looks like. So we're going to plug in some numbers here. So the absolute value of -1 would be 1. Absolute value of 0, 0. Absolute value of 2, 2. Absolute value of 4, 4. So we'll graph those. -1, 1. 0, 0, 2, 2, 4, 4. So notice, guys, it makes some form of like a wee. Ooh, can't draw lines. Makes a V for us. So my domain, the farthest X I get, -infinity. And I keep going that way too. So I am infinity as well. Range, starting at 0, because bottom to top, to infinity. He is continuous, because remember, continuous means I can pick up my pencil. I don't have to pick it up as I draw. He's even. He folds along the y-axis. Really neat about him. Maximum, none. But he does have an absolute maximum of infinity, because he does go up there. Minimum would be at y equals 0, at x equals 0. That would also be your absolute minimum. Intervals of increasing, so it looks like we're increasing on the domain from 0 to infinity. Whoop, parenthesis, 0 to infinity. We're decreasing from -infinity to 0. Notice, guys, how this kind of puts together to make your domain. That should always happen. We haven't talked about end behavior yet, but it's actually not too hard. As my x goes to -infinity, this is goes to -infinity. So as I go this way, what is the graph doing? Well, it's going to infinity. As I go to the left, that's what this is saying. As I go to the left, what is the graph doing? It's going to infinity. As I go to the right, my graph goes to infinity as well. X-intercept at 0, 0, and so is my y-intercept as well. So keeping in mind, this is what the parent looks like. All graphs of absolute value should be a V. Some of them might be moved around, they might be a little more skinnier, they might be flippied, bunch of different things. So let's take a peek at how to graph with a table. So very first thing you're going to want to do is you're going to want to find where is what's known as your vertex. Your vertex was right here. This was your vertex. Basically where the V starts. So to find that, you're going to want to set whatever's in here equal to 0. So x plus 3 is equal to 0. So it looks like my vertex is at -3 for an x value. So I'm going to put my vertex in the middle of my graph. So -3. And then I need to give it some groupies around that -3. So like -4, -5, -2, -1, that kind of thing. So let's plug in some values, shall we? So -5 plus 3 in the absolute value minus 4. Well, -5 plus 3, that's a -2. Absolute value of -2 will be 2. So 2 minus 4, that will be -2 there. Let's plug in a -4, so that would be absolute value of -4 plus 3 minus 4, which would be absolute value of negative 1 minus 4, which would be negative 3. Plugging in negative 3 would be 0 in the absolute value, which would be negative 4. Plugging in negative 2, I'll get 1 inside. Absolute value of 1 is still 1. Minus 4 is negative 3. This will be negative 2. Notice, guys, this guy, they should always do this. Should always kind of wrap around, kind of like a parabola when you guys graphed quadratics in Algebra 1. This should happen as well. It should always kind of overlap. You found your vertex was at negative 3, negative 4. So we can kind of graph that here. Negative 4. Negative 4, negative 3. Negative 2, negative 3. Negative 5, negative 2. There's my V for value. Intercepts. Oh, I'm a little off. I'm going like, whee, like that. So it looks like I have an intercept at 1, 0, and oh, where's that crossing? Negative 7, 0, and 0, negative 1. Going off to the side here. So we have right here cross, we have a cross here, and then we got a cross there. Got a couple of crossing there. We are continuous. Bounded, we are bounded below on this one because it does keep climbing, but it doesn't go any lower. It has an absolute minimum. This guy, he is not even. Notice it can't fold along the y-axis. He's also not odd, so he is a neither graph. Increasing, I am increasing on my domain from negative 3 to infinity. Decreasing, looks like it's from negative infinity to negative 3. Absolute value, you're always going to have only a min or a max. This case, I have a minimum, and his minimum is at negative 4 when x is negative 3. And that would be an absolute minimum. That would be the absolute minimum. Domain, negative infinity to infinity, because I go all the way to the left and I go all the way to the right. Range, however, looks like I'm starting at negative 4, and then I'm going to keep going up, up, up. So to infinity. Let's try another one. So, let's set what's underneath, what's inside here equal to 0. Subtract 1. Divide by 2. I get negative 1/2. So that's my x value. Gross. Let's go ahead and put some groupies around him. Let's go negative 1, and then I'm going to start counting by full ones. This would be 0 and then 1. So, plugging in negative 2, I'll get 2 times negative 2, negative 4, plus 1, negative 3, absolute value, that would be 3. Tack the negative back on, so that would be negative 3, plus 3, that would be 0. Be careful with this negative out here. A lot of people forget about him. And he does not distribute in. Absolute value bars are not like the parentheses. You gotta take care of the inside first. Let's plug negative 1 in. So 2 times negative 1, that's negative 2, plus 1, that would be negative 1. Absolute value, 1. Tack the negative back on, negative 1, plus 3, that'd be 2. Negative 1/2. That gave us 0 here, so this would be 3. 0, that would be 1, negative 1, 2. This should start matching again. Checking to make sure it does. 3, yeah, 0. So my vertex is at negative 1/2, comma 3. So negative 1/2, comma 3 right there. Negative 2, 0. 0, oh, negative 2, 0, 0, funky little guy. There we go. There we go. Notice, guys, he's kind of like an inverted V. He's gangster V. Intercepts. Got a couple of intercepts here. Got one at -2, it looks like. Got another one at 1, 0, and then we also had one at 0, 2. Got a couple of X's intercepts and one Y. Continuous. All of them will be. Bounded. We are bounded above this time. Something different. Notice, because he doesn't have anybody on top. He is neither on even odd. Increasing. It looks like we are increasing from -infinity, because it's my car here. Beep beep. He's going to go all the way up to my X value right here, which is -1/2. And then we're going to decrease from -1/2. Whoa, can't draw. Can't draw. That's 2 right there. Goes right underneath there. Comma. Infinity. We have a maximum of y equals 3, and it's when x is -1/2. Domain, (infinity to infinity). I'm going to tell you a secret, guys. Absolute value graphs, that is always the domain. Super awesome. Range changes a little bit, however. Range, notice it goes up to 3. So we start at -infinity, because it keeps going down, but we go up to 3. So, for a summary, what do you need to remember about this? Absolute value graphs are V. V for value. Find the vertex first by finding the x value that makes the absolute value expression become 0. So what's inside the absolute value bars? Set that equal to 0. Complete your table. Plot the points. It should always be a V. If you only get a straight line, you didn't find the vertex correctly. Bad, bad, bad. You should always get a V. Giant V for values. And that's the end of this video. See you later, Sabers.